Most of the bleves that you will see in this video were deliberately induced by impinging severe torch fires on the tanks. In some cases, the tank shells were mechanically weakened. The term BLEVE stands for Boiling Liquid Expanding Vapor Explosion. We find liquefied gas tanks everywhere around us. There are approximately 1 million propane storage tanks and 14 million refillable cylinders in use across Canada, including in our own backyards. Yet because of their sturdy construction and safe storage and handling practices, very rarely do we ever have a tank BLEVE. A pressure liquefied gas, or PLG, is a substance that would be a gas at normal atmospheric pressure and temperature, but it is commonly stored and transported as liquid under pressure. The most common pressure liquefied gas in use is propane. At 20 degrees Celsius, propane is maintained as a liquid as a result of being under a pressure of 121 pounds per square inch, or 834 kilopascals. At the critical temperature of 97 degrees Celsius, propane cannot be maintained as a liquid regardless of pressure. At minus 42 degrees Celsius, propane will remain in a liquid state at atmospheric pressure. If a pressure liquefied gas container fails, resulting in a sudden loss of containment and a sharp pressure drop, the result can be an explosive release of vapor and boiling liquid. That is a BLEVE. The BLEVE is a physical explosion with accompanying hazards of blast, flying projectiles, and a vapor cloud. The substance does not have to be flammable to BLEVE. However, if the substance is flammable, such as propane, then the additional hazards of fireballs and thermal radiation will most likely occur. A BLEVE is a low probability event with high consequences. It can be devastating.
Rare though it is, a BLEVE is among the greatest dangers you can face as a firefighter or emergency responder. Through an accident or a fire, a BLEVE can occur with any of these tanks. You could arrive just in time for the blast and have jagged steel projectiles flying at you. BLEVEs can happen in places you might expect. A fire in a tank storage area, a tanker truck accident, or a tank car derailment. They can also happen in places you don't expect, where you may not even know there's a tank. For example, barbecue propane tanks, inadvisably stored in basements, sheds, or emergency stairwells.
Or you arrive at the scene of a fire in an outlying area. A barn is burning. It looks like a routine operation, but there's more here than meets the eye. Out of sight behind the barn is an LP gas tank right up against the building. This installation is dangerous. Flames are impinging on the side and top of the tank. It is a recipe for disaster. Inside the tank, the heat is vaporizing the liquid gas, increasing the tank pressure. To limit the pressure rise, the pressure relief valve goes to work. However, in relieving the pressure, the PRV also lowers the level of the liquid in the tank. The flame now impinges on the tank above the liquid level, causing the wall of the tank to heat up. The heat builds up to high temperatures, weakening the steel critically. The weakened metal under pressure allows the tank to fail. The BLEVE erupts with a huge fireball and thermal radiation. It sends out a shock wave and sends tank fragments rocketing. The danger zone for projectiles is the greatest. The BLEVE of a large tank can propel tank fragments, pipes, and other debris 1,000 meters and more.
What you've just witnessed happens quickly. The weakening of the tank shell by heat can take just minutes with a severe flame. Tank failure and the BLEVE itself occur in a fraction of a second. Let's take a closer look at what can happen.
Exactly how does fire cause a tank to levee? The fire heats the tank walls rapidly and unevenly, driving up wall temperatures over the vapor space much faster than where the liquid is in contact with the tank shell. As the PRV cycles to reduce the pressure, gas escapes, lowering the liquid level still more and exposing more vapor area of the tank shell to the rising temperatures. As temperatures soar, the steel walls rapidly lose strength. Wall temperatures quickly reach 400 degrees Celsius over the vapor space, weakening the steel by 30%. Above 600 degrees Celsius, steel strength drops dramatically. By the time the wall reaches 700 degrees Celsius, minutes later, the steel has lost 90% of its strength. Under pressure, the thinned and weakened shell fails.
It's amazing how quickly steel weakens at high temperatures. That's why a tank subjected to a strong torch flame can levee so quickly, anywhere from 3 to 12 minutes, depending on its size.
Which size of tank is likely to levee sooner, large or small?
The answer is, small tanks are likely to levee sooner. Small tanks empty sooner, heat up faster, and with thinner walls, can fail more quickly.
With a severe flame heating tank wall temperatures to 700 degrees Celsius, a small 400-liter tank can levee in as little as 3 or 4 minutes. A 4,000-liter storage tank can fail in 5 to 7 minutes, and a big 40,000-liter tanker truck can go in 8 to 12 minutes.
Damaged or corroded tanks may levee sooner, or if the flame is less severe, they may levee later, by minutes, hours, or even days. Tanks exposed to fire are dangerous, whatever their size. As you see, a tank can levee at any time, the moment you arrive, or minutes, hours, or days later. And if and when it goes instantly, with absolutely no warning. Don't expect to see bulging or hear pinging noises.
This tank has been deliberately weakened to demonstrate how quickly and without warning a tank can fail.
So rule 1, if you at all suspect that there is a liquefied gas tank exposed to fire, you never go in immediately and try to attack the fire. Firemen have died doing just that. You stay way back until you can size up the situation through binoculars. What is a reasonable distance for emergency responders to approach in assessing a potential levee situation? This is a key question.
A levee involving a flammable substance poses 4 main dangers. Fire. Thermal radiation from the fireball. Pressure from the blast. And flying projectiles, with the projectiles being the farthest reaching danger of all.
First, let's look at the fire hazard. If the release is ignited, there's an immediate fireball.
Tests show that when a 400-liter propane tank levees, the radius of the fireball is about 18 meters. For a 4,000-liter tank, the fireball radius more than doubles to 38 meters. And for a 40,000-liter tank, it more than doubles again to 81 meters. Heat will be radiated in all directions.
A rule of thumb for measuring the danger zone from thermal radiation is this. Firefighters in protective gear and breathing equipment should be no closer than 4 times the radius of the fireball, down to a minimum distance of 90 meters.
For a 400-liter tank, that translates into a minimum observation distance of 90 meters. For a 4,000-liter storage tank, it is 150 meters. And for a 40,000-liter tank, it jumps to 320 meters.